All right, hello everyone. I am here at NYU Future Labs talking to some of the AI Nexus batch companies. And right now I'm here with Jeet Rout, who's the CEO of Behold.ai. Great to have you on the show, Jeet.
Yeah, thanks for having us, Sam.
So Behold.ai, Behold, that's a bold name. What are you guys up to? What problem are you going after?
Sure. So our main focus is basically using some of the latest advancements in natural language processing to help automate and make medical billing and coding more efficient.
Okay, what is it about that problem that lends itself to AI, or what's the problem there? I think we all have a sense of it, but maybe you can help characterize it for us.
Absolutely. One of the biggest problems currently in medical billing is the fact that there's a high level of errors. Mm-hmm. And this is due to a variety of reasons, but one being that there's a variety of codes being used on both the billing and insurance side that have to be regularly updated, and that a lot of current billers have been around for a long time, and just kind of due to the nature of how medical technology is, tends to be a bit slower and a bit further behind. Mm-hmm. So right now, a lot of hospitals and clinics actually end up faxing over medical records for medical billers to actually parse through manually. So they fax them over, they're printed out, and then someone sits there and manually looks over them and types it into a different computer system. And this is the way it's done mostly in 2017. So it's just an incredibly antiquated system.
Wow. So it's not, I envisioned, everyone has Epic, the electronic medical record system, and the insurer, there's some electronic exchange of information based on the ERM. That's not the way it's happening out there.
Yeah. So what ends up happening is that you're absolutely right about EMR systems such as Epic, Cerner, Allscripts, these major players in the space right now. The problem is that, it's kind of twofold. One is that a lot of this data is siloed due to a variety of laws, including HIPAA. A lot of the data is kept within data centers in the hospital, and they're very reluctant to set up cloud-based API systems to easily transfer the data. Okay. And then the other problem is that a lot of medical billing companies they tend to be a lot of mom and pop shops that have been doing this for decades now. But the way it's been done for the last 20, 30 years is just the way it's been done now, just because setting up all the integrations, getting all the technology working with each other is outside of the expertise and the scope of what a lot of billers have been up to. So what we're really trying to do is kind of just help the whole process become more efficient. Okay.
So today, most service providers outsource billing to some other, like a large hospital system. Would they typically have inside billing, or they would also outsource it?
Sure. So a large hospital system, if it's large enough, would actually have it in-house. Okay. But a mid-size or anything smaller, there's a good chance they'll outsource it. A big reason is just the overhead and the cost. Sure. There's a lot of specialty shops, especially abroad, that specialize in medical billing. And yet again, it's just a matter of it being just much cheaper to do. Okay. But yet again, with that, another big problem that happens is that you just have a large number of mistakes. Mm-hmm. There's a NerdWallet report saying that basically close to 50% of all Medicare claims sent through the Centers of Medicare and Medicaid Services actually have some sort of error. So the error rate is actually extremely high. And what that means for us as patients and for payers and providers is that it's a 26% increase in total costs for healthcare.
Wow. And 20% of the, I mean, we all, I think, look at healthcare as being an area where there's a lot of inefficiencies, right? But there are folks are estimating that 25% of that is just due to miscoding insurance claims.
Yeah. And a big, I mean, to put that into perspective, if you're talking about a $3.2 trillion annual spend on healthcare, that's $800 billion, right? It's in things that can be reduced. That's bigger than the market cap for Apple. That's like, if it was its own country, that would be the 16th largest economy in the world. So this is just a massive problem.
Wow. Well, I normally ask what made you want to go after this problem, but it's kind of obvious. But how did you personally get to this problem, and what were you doing before?
Sure. So when we started off our company, we were actually more focused on computer vision within the medical space. So that's why part of the Behold name comes from the vision part of that. So one of the more difficult things that we ran across was we actually built out a platform that can help analyze medical images and help detect abnormalities in areas and help, even triage images for radiologists to look at, ophthalmologists to look at.
Okay.
So one of the problems we came across there was in our process was not even the technical problem of this. It's doable, but more of the kind of go to market and getting in everywhere, getting integrations in and kind of getting the write off from the C-level radiologists and the IT. So it's a very drawn out process. And then we started thinking about other applications of using computer vision. And one thing that we came across was the fact that there's this very archaic process right now. So even one of the first things that we started doing was using some existing optical character recognition technologies to convert the faxes into digital form. So one of the first things that has to happen is that when the faxes get sent over, the coders have to literally retype in the information, which is an extremely inefficient use of their time.
Yeah.
So even little things like that right off the bat can help really speed up this process.
It's amazing how technology moves. 20 years ago, people were talking about all of the, the fax stuff going away to EDI and APIs and stuff like that. And now you're telling us that basically fax is the universal API for insurance billing, and you actually have to do something to make that intelligible. Yeah. So you have all these fax images. You allow someone to, or you allow who's your customer? The provider, the payer? Where are you in this?
So currently,
chain?
the model we have right now is the provider. The idea being that they are the ones who directly just need the service done. So what we do on our side is we can take the fax over records, we can digitize them, and we can start process them. We still have a human who looks them over and makes sure that everything's good. But what's great about this is over time, and then we'll actually have that submitted to a claims gateway for a payer.
Okay.
What's really useful about this is that we'll actually get the feedback on this. So this is where this becomes really important for training our model, where this active feedback loop will actually help our kind of algorithms get really good at this over time. So our biggest thing right now is that can we parse through something quickly, and then just a regular biller can just look at it, and we can generate these codes automatically, and then they can just just agree with the codes right away. So they can say this is correct, this is incorrect. They can still adjust it after the fact. Okay. But still, this provides a huge level of efficiency increase over the current system right now.
Got it. And so you guys are essentially the provider would choose you guys in place of whoever their current coder is, and you would essentially code for them with the option of later on kind of doing the whole end-to-end billing piece.
Yep, exactly.
So you could say kind of Uber for insurance coding. Hopefully you don't use that analogy.
Yeah, maybe not. Maybe Uber, maybe a Lyft. Yeah. Yeah, I mean, that's kind of the idea right now, is the fact that right away we can make it efficient just by cutting down on the inefficiencies of more archaic technologies. But over time, once we actually have these models trained out, we can actually make it not only much faster, but much more efficient in terms of reducing error rates and actually helping providers take in more money. And making sure also even for patients, because what ends up happening is that excess cost, like you or I cannot look at a billing sheet and decipher it very well and understand what's happening on it. Right. It's also going to be beneficial to all patients. Right. To use that provider.
So you brought some vision technology over from the original idea behind Behold, which helped you understand, what was on the fax, but then you probably needed some NLP and other technologies to actually interpret the fax. Can you talk a little bit about what you're doing there?
Sure. So for the basic kind of, we were using neural networks for the computer vision part, where we had images trained out with these labels, and then over time, the computer could actually discern between different labels on images completely on its own. Okay. So for the when we're dealing with the medical billing, it's a little bit different, where one of the first things we're doing is reading a form. Because what ends up happening is that a lot of these forms are predefined. So there it's actually a little bit simpler, just using optical character recognition. Where it becomes more interesting is for the OCR, once you actually have the medical record or the procedure record or the procedure notes, that's actually where the NLP comes into play. And that's where we're using a variety of methods. Both, we'll have names of procedures in a database. We actually map out what we think procedures are from those medical notes, generate what's called an ICD-10 or 9 code, which is basically a disease code used internationally, which correlate to a CPT code, which are the reimbursement codes for payers. So the idea being that once we generate the disease code, we can generate the billing code and then pass it on to claims. So we can just improve that whole pipeline there, just using the natural language processing.
Is there any AI? So is there a one-to-one mapping between diseases and claim codes, or is there some intelligence that has to be applied there as well?
Sure. There it's not necessarily one-to-one, but what ends up happening is that you can have one disease code that has a variety of different billing codes. Because, for example, you could have one disease code that requires a variety of different procedures done. So there, it's not using.
But it's kind of deterministic. It's not
exactly
you're trying to figure anything out there.
Right.
Okay.
So the biggest thing, honestly, is going from here's some text, here's some short form notes, and converting that to the disease code, and that's where the biggest advantage comes in.
And are those short form notes? Are we still dealing with handwriting at this point, or is it all typed text on a fax?
Sure. With the ACA, a lot of doctors actually have to type up digital notes. So digital notes are required. So the good thing is that while there are faxes involved, for the most part, there's no handwriting here, which is really good. So we're at least beyond that point.
Yeah. Okay. Interesting. So what have you learned in the process from a technology perspective, or what have you found? What surprised you? Once you made this pivot to going after the healthcare space or the insurance billing space from a technology perspective.
Sure. One of the more interesting things is there, as you mentioned with Epic and the other EMR systems, is kind of how the fact that it's interesting that a lot of them don't necessarily have a cloud-based platform. There are a couple, but for the most part, almost everything tends to be locally stored on hospital servers, and kind of communication between the two. So there's a standard called HL7, which is the way that EMRs can universally communicate with each other. For the most part, I mean, especially as a patient, I think one of the two things. First of all, that the data, like you can think that we own the data. We don't. It's kind of this gray area. Data ownership is actually it's still mostly on the hospital. The hospital owns the data, all of our medical data. The other thing being that just communication between the systems is very complex, not from a technical standpoint, but from more of the integration standpoint, making sure all these things communicate with each other. But that ability to communicate, that transparency, is actually highly effective, because there could be a lot of times when, let's say, you go to a different clinic or you move, it's very difficult to actually send over your medical records. So what'll end up happening is the fact that your eye could easily go in for procedure and get more tests done, redone, even though you have the record elsewhere. So to me, I think just uncovering more and more of the inefficiencies within medicine itself that would seem like they'd be pretty solvable given today's more common technologies.
And 5 years ago or so, this is probably due to the ACA, there was a big move towards these HIEs, healthcare information exchanges. Is that still happening, or is that all kind of stalled out?
It's still going on, but it's just such a long procedure. And I think, over time it'll have to be realized, mostly because as we go forward with medicine, a lot of, especially CMS is looking at more repayments based on population health statistics and outcomes versus fee for service. So as we move more towards that model, these health information exchanges are incredibly important, because otherwise we're not really sure what data we're looking at. And more than anything, we need to be more cognizant, or the healthcare system needs to be more cognizant about what they're repaying and what they're doing, so we can really cut down on costs. Because ultimately, over time, the way that we're doing it is just not sustainable from the U.S. economy.
Right. Well, if you weren't going after the insurance market, what are a few other opportunities for applying machine learning and AI in healthcare that you've come across?
There's a lot of more simple things, even just optimizing for. There's been companies that have done really amazing things with just things like optimizing for lighting, optimizing for
lighting.
It sounds kind of like, it sounds a little bit weird, but even like the lighting on the mood that patients have, adjusting for that intelligently, even just like use of space, there's a lot of ways to optimize many of the kind of inefficiencies that hospitals have today. I think right away we go to this kind of really, really technologically deep, like deep learning, using like the latest AI stuff. But honestly, a lot of the inefficiencies of hospitals are just simple things that could just be done more intelligently.
Well, great. I've really enjoyed this conversation. Anything else you'd like to mention about what you guys are up to?
Yeah, I mean, for us right now, one of our biggest goals is we're working on a pilot with a cardiology clinic out of Nevada.
Okay.
And then down the road, one of our biggest things, trying to scale this out is to go to a variety of different hospitals and clinics, working with a variety of different data sets, because one of the things that'll be most valuable will be how robust we can make our algorithms and how they can work on a variety of systems. So we'll look forward to the challenges and see what lies ahead.
Great. And where can folks learn more?
Sure. So if you go to our website, Behold, behold.ai.com, we have a bit about what we're doing, a bit of the basic overview of the technologies, as well as some things about our team and kind of updates on what we'll be doing in the future.
Okay, great. Well, thanks so much, Jeet.
Yeah, thanks a lot.
Great talking with you.
Yeah.